When you're building the most powerful rocket ever, it takes a lot of folks developing a lot of technology and a lot of hardware. So we're taking advantage of the SLS program to support it, but also develop some new technology. This current SLS test program is basically focused on getting some acoustic data for the vehicle that will help us to design the water suppression system on the launch pad. For this program, we actually made a full mock-up of the entire vehicle, including models of the liquid engines and the solid rocket boosters. The SLS program actually uses the same main engines as the space shuttle. So in order to do this testing for the acoustics part of the SLS vehicle, we actually use the exact same engine models that were used on the space shuttle program when they were going through acoustic testing. The actual engine models are just some really simple thrusters. It's a simple injector, thrust chamber, and nozzle design. And even though it's really simple and old hardware, we bring it out from time to support some different programs. For this acoustic model testing, we didn't have enough injectors in our inventory, so we actually had to make some new ones. The traditional technique actually uses a lot of intensive machining. There's a lot of different parts to machine. For our new injectors, we actually bypassed all the machining and welding and brazing and actually made these new pieces in one piece with selective laser melting, which is a 3D printing process. And with this process, we actually fabricated these in-house in one piece, so we got rid of all of the 32 braze joints and all of the 5 welds. We've actually got over 20 hot fire tests done on these units on the acoustic model so far. And as far as performance goes, they have the same performance or even better performance than the traditional injectors. And they've held up really well. After 20 tests, we haven't seen any degradation of the part.